Today our discussion is about Hoffman degradation or Hoffman rearrangement reaction. Uh, it is in class 12 and in unit 13 and the unit 13 the name of the chapter is nitrogen containing organic compound. We can use as reactant in this case, that is amide, and the reagent for this reaction is halogen, that is chlorine, bromine, or we can use iodine also, and one strong base we need to use. This is maybe NaOH or maybe KOH, and the product of this reaction is primary amine. Now we give an example. This is an amide. CONH2 group is the amide group, and R may be in this case maybe alkyl or maybe aromatic. And if we use bromine and NaOH, that is halogen on alkali, then the CO group of the amide is eliminate and form RNH2, that is primary amine. So the one carbon from the amide is decreases, so this is named as step down reaction. So this is a step down reaction, so the number of the carbon decreases. The carbon from the amide group is decreases, so it is a step down reaction. Now we give the specific example, that is acetamide, or the UPAC name is ethanamide. When we use halogen and alkali, there is chlorine and NaOH, CO group from amide is eliminate out, so it form CH3NH2, that is CH3NH2, this is methyl amine. And when we use benzamide, the CO group of the amide eliminate, so it form aniline, this is aniline. And what is the mechanism of this reaction? Firstly, the lone pair of the nitrogen of amide group donate or attack the bromine molecule, that is halogen molecule, and eliminate one Br minus anion, one Br minus anion, and form this ion. In this case, nitrogen has one positive charge, so it want to neutralize, and the bond between N and the bond of the electron between N and H is neutralize the N plus charge, and one H plus eliminate out. So it form the N bromamide. This is N bromamide. Now what you can notice, what is must notice in this step, there is one H from the amide group substitute by one Br atom, bromine atom, and this is the substitution reaction to form the N bromamide from amide. Now the second step is the acid base or neutralization reaction. The alkali or the OH minus ion from the alkali react with the H remains with the amide group. This is the most acidic hydrogen one, and eliminate one H2O, and the electrons between NH bond reside on the N atom, so it forms N bromamide anion. This is N bromamide anion. Next step, this is the rearrangement reaction, and the negative charge of the nitrogen atom form a double bond between C and N, and as the carbon already has 4 bond one is here, and two is between two bond are between C and O, so it has already 4 bond. And if the minus charge form another bond, so carbon has 5 bond. This is impossible, so are rearranged rearrange the position from C to N, and Br minus eliminate out. This form R N double bond C double bond O, R N double bond C double bond O. This is isocyanate. In next step, this is the addition reaction. What for it is addition? The bond between N and C break up, and the water molecule add with the N and C. The positive part from the water molecule bonded with the N, because it is positive, it is negative one, and the negative part from the water added with the carbon, because it is positive one according to the electronegativity difference, because N is higher electronegative than carbon atom. And in last step, there also one rearrangement reaction occur. The electron between O and H form a double bond between C and O, and as also the carbon has already 4 bond present, 1 2 3 and 4, and one bond which form OH, it may form 5 bond on carbon. This is impossible, so the bond between N and C breaks, and the H plus we get from OH, it rearrange to their position and join with the N of the isocyanate group, and so CO2 molecule eliminate out and form RNH2, that is RNH, and one H come from OH group, that is RNH2, and this bond break, so CO2 molecule form. This CO2 molecule is formed. So here is the main product is primary amine. This is you must remember, there in this reaction we form primary amine from amide, and one carbon decreases in this reaction, and the carbon decreases from the amide group. You must remember this point for this reaction. Thank you.